This video is about what is multiplication and estimating multiplication. So the definition of multiplication is repeated addition. So we're adding the same number to itself several times. So for example, 4 times 12 can be interpreted as 12 added to itself 4 times. Doing that addition, 12 plus 12 is 24, 12 plus 12 is 24, 24 plus 24 is 48. So 4 times 12 is 48, 4 times 12, 12 added to itself 4 times. Or we can think of this as 4 added to itself 12 times. So it's 4 added 12 different times. Add those up. 4 plus 4 is 8, plus another 4 is 12, plus another 4 is 16, plus another is 20, plus another is 24, plus another is 28, plus another is 32, plus another is 36, plus another is 40, plus another is 44, plus another is 48. So if I add 12 4s, I get to 48. And notice 4 12s and 12 4s both get us to 48. Here's an example using repeated addition. So now I have 3 times 2.5. So this is 2.5 added 3 times. So there's 2.5 plus 2.5 plus 2.5. So 2.5 plus 2.5 is 5. And then I add this other 2.5. 5 plus 2.5 is 7.5. So 3 times 2.5 is 7.5. Or this is 3 added 2.5 times. So again, that's 3 added 2.5 times. So here's 1 3, here's a second 3, and then we need half of 3. Well, 3 plus 3 is 6. Half of 3 is 1.5. 6 plus 1.5 is 7.5. So again, we have done a multiplication computation, thinking of it strictly as repeated addition. So 2.5 added 3 times, or 3 added 2.5 times. A decimal example of multiplication as repeated addition, 3 2/10 times 5. This is 3 2/10 added 5 times, 1, 2, 3, 4, 5 times. 3.2, add a 3.2, you get to 6.4, plus 3.2 gets you to 9.6, plus another 3.2 gets you to 12.8, plus another 3.2 gets you to 16. So I'm just adding 3.25 times. If the way I have this set up is a little bit confusing, some of you will prefer to add them by stacking them and writing them something like this, and then doing the addition, and that's fine too. Or 3 2/10 times 5 can be thought of as 5 added 3 2/10 times. So now I have my 3 5s, 1, 2, 3, and then I need to figure out 2/10 of 5. So to figure out the 2/10 of 5, that's a little bit harder part. So I'm taking the number 5, I'm breaking it into 10 parts. Well, if I take 5 and I break them into 10 parts, that means each one needs to get broken into 2 parts. And so I end up with a half, or 5/10. So 5 broken into 10 parts means that each part is a half. And then I'm going to need 2 of those. So my 5 plus 5 plus 5 from up top became 15. And then my 2/10 of 5 became 1/10, 2/10, which gives me 16. So 15 plus a half is 16. So again, notice whether we did 3 2/10 5 times or 5 3 2/10 times, we still end up with 16. And we're merely evaluating multiplication by using repeated addition. So we're just adding the same number a certain number of times. Okay, so let's now talk about estimating multiplication. So we're going to first do estimating with decimals in decimal form. So for whole numbers and decimals, we first need to look at how the size of the number affects multiplication. So we're going to focus on the tens. So multiplying by 10, dividing by 10, that's really going to help us figure out how big these are. So I want you to grab a calculator or pull up a calculator on your computer, and I want you to punch in these three. So feel free to pause this video now and find out the answers to these three. Okay, hopefully you did that, and hopefully you got 50, 90, and 1,870. Now, if I asked you to come up with a rule for what happens when you multiply by 10, a lot of you are thinking in your head, oh, you just add a zero. Well, you're not adding a zero. Plus zero doesn't change the number, but I know what you're thinking. You're thinking, oh, I just put a zero at the end of the number. Okay, so try these. Again, bust out your calculator, pause this video if you need to, punch in these three and see what you get. Hopefully you got these answers. So now, looking at these numbers, hopefully you're noticing pretty quickly that that rule of thumb of just putting a zero on the end isn't going to work. Okay. For example, if I took the 4 2/10 and I just put a zero on the end, then I would have ended up with 4 20/100ths. That's just sticking a zero on the end, but that's exactly the same number. 4 2/10 is the same as 4 20/100, so that can't possibly be the right answer. I multiplied by 10, that number should be getting larger. So if we want to think about this a little bit differently, just the putting a zero on the end isn't going to work once we have things that are no longer whole numbers. So instead, what we're going to do is we're going to think about this as shifting place values. Okay, so what I mean by that is this 2 starts out in the 10th place. But when I multiply by 10, it gets bumped up to the ones place. So it's getting shifted one place value larger. Same with the 4. The 4 is in the ones place. I multiply by 10, it gets bumped up to the next higher place value. Ones become tens. So now I have the 4 in the tens place and the 2 in the ones place. So it's getting bumped up. If you notice on this question below it as well, so here's the 7, tenths, hundredths, thousands, 10,000s, 100,000s, millions. It gets multiplied by 10 and ends up in the tenths, hundredths, thousands, 10,000s, 100,000s. So it went from the millions place to the 100,000s place. It got shifted up one place value. And then same thing for that last example. So we're going to really try to think of these as shifts. So every time we multiply by 10, we do one place value shift so that the number gets larger. Okay, so let's see what happens when instead of multiplying by 10, we multiply by a tenth. So again, punch these in your calculator, see what happens, try to come up with a little rule. Hopefully you got these as your answers, punching them in your calculator. So now what appears to be happening, if we keep this idea of a place value shift in mind, now we're shifting in the other direction. So looking at the first example, if I look at the 5, it's currently in the ones place. When I multiply by a tenth, it goes to the tenths place. It got shifted one place lower. Coming over and looking at the 4.2, the 4 is in the ones place. I multiply by a tenth, it ends up in the tenths place. The 2 starts in the tenths place. It gets multiplied by a tenth, so it gets shifted to the hundredths place. So we're going to think of these as now getting shifted down. So one place value down every time we multiply by a tenth. So these are going to be our two rules that are going to help us figure out the magnitude of these multiplications. In other words, how big they are. So every time we multiply by 10, we shift the number one place value. Every digit gets shifted one place value so that the number gets larger. When we multiply by 1/10, every digit gets shifted one place value so that the number gets smaller. So now the task becomes, how many places do we shift and in what direction? So here's an example. 6 times 400. So here's what we're going to do. We're going to break apart the tens. We're going to try to find where we're multiplying by 10 and where we're dividing by 10. So what we did here is we broke the 400 into 4 times 100. 6 times 400 is exactly the same as 6 times 4 times 100. Okay, we started with multiplication, we split with multiplication, so we're all set. So then what we're going to do is we're going to multiply the 6 and the 4. All right, so 6 times 4 gives us 24, and then we still have this 100 hanging out. So what we're going to do is we're going to think about how many tens is that. Now, as you get more comfortable with this, and some of you might already be there, you're not going to need to write out that 100 is 10 times 10. But I find it helpful just to see it so that I can see every single 10 that I am multiplying by. So here I have 24 times 10 times 10, which means multiplying by this 10 is giving me one shift larger. Multiplying by this 10 is giving me another shift larger. So this is going to be 24 with 2 place value shifts so that the number is larger. So here we are. The 24 is currently in the ones place. So it started here. It needed to go 2 shifts. Boom, boom, ends up in the hundreds place. The 2 started in the tens place, so it needs to go 2 shifts. 1, 2, ends up in the thousands place. So multiplying by 100 gives me 2 shifts larger. What about a number like this? So now I have 8 times 50,000. So pause this video and see if you can break it down. Find the tens. Okay, let's walk through it. 50,000 can be broken into 5 and 10,000. And where that's coming from is that the 5 is in the 10,000s place. So there's my 5 times 10,000. Then 8 times 5 is 40. So I now have 40 times 10,000. And 10,000 can be broken into 10 times 10 times 10 times 10. And if you're not really sure, then just sort of start to walk yourself through it. So 10, that's one of them. If I multiply that by 10, that's a shift. So that's 2 of them. If I multiply that by 10, that's another shift. So that's 3 of them. If I multiply by 10, that's another shift. Okay, now I'm in the 10,000s place. So that was 1, 2, 3, 4 tens. So there's my 1, 2, 3, 4 tens. So what does this mean? This means 40 with 4 place value shifts larger. So the 4 is starting in the tens place, so it needs to shift 4 times. So there's tens, hundreds, thousands, 10,000s, 100,000s. So that 4 needs to land in the 100,000s place. So 40 with 4 place value shifts larger ends up to be 400,000. Now, here's another situation where you got to be very careful about that 0 thing going on, right? Because there are 5 zeros in this number, but there were only 4 shifts. Because one of the zeros comes from the 8 times 5 is 40. So you're taking a number that ends in 0 and then you're doing some shifting. So I don't want you to think about, oh, well, I multiplied by 10 4 times, there better be 4 zeros. No. It has to do with shifting. So I'm taking 40 and I'm place value shifting that up 4 times. Okay, so what about something like 7 times 2 thousandths? So now I'm multiplying by a really small number. When I multiply by a small number, that number needs to get smaller. In this case, the 7. So we're going to break this up. So the 2 thousandths is going to be broken up into 2 times 1 thousandth. Now I can do my 7 times 2 is 14. And now I need to find the tens. How many tens, in this case tenths, did I multiply that 14 by? So I'm going to break this down. This 1 thousandth becomes a tenth, a tenth, and a tenth. Again, if you're not sure, then start to walk yourself through it. So start with a tenth. If I multiply that by 1/10, then everything gets shifted one place value. So we're going in this direction. Multiply by a tenth again, it gets shifted down. In this case, that's as far as I need to go. So that's multiplied by 1, 2, 3 of them. So there's my 1, 2, 3. So this means 14 with 3 place value shifts, and this time those shifts are going to go smaller. So the 4 is currently in the ones place, so it needs to go smaller. So it's going to go to the tenths, to the hundredths, to the thousandths place. The 1, same idea, starts in the tens place. It's going to go to the ones, the tenths, the hundredths. So 14 with 3 place values shift smaller. I broke down the shifts so you could see them. So here is with 1 shift, shifted another time, shifted another time. So 7 times 2 thousandths is 14 thousandths. So pause this video, try this one on your own, see what you get. Then we'll go through it. So we're going to break the 5, and let's figure out what this number is. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this is 500 thousandths. So we're going to break this into 5 times 100 thousandth. Now we're going to multiply the 4 and the 5 to get the 10, and we're going to keep the 100 thousandths. And we're going to break that 100 thousandth into 1, 2, 3, 4, 5 tenths. So again, walk yourself through it just like we did on the other ones. So I'm going to start with a tenth, and then if I multiply by a tenth, and then if I multiply by a tenth, and I keep multiplying by a tenth until I get to the number I need. So that would be this number. So I multiplied by 1, 2, 3, 4, 5 tenths. So there's my 1, 2, 3, 4, 5 tenths. So I'm taking 20 and I'm shifting it 5 place values smaller. So again, I'm going to show you the shifts. 20, 1 shift smaller, another shift smaller, 3, 4, 5 shifts smaller. Looking at the 2 starts in the tens place. It's going to shift to the ones, to the tenths, to the hundredths, to the thousandths, to the 10 thousandths place. So that 2 ends up in the 10 thousandths place. The 0 ends up one place smaller than that. So there's your 100 thousandths place. So 4 times 500 thousandths is 20 100 thousandths, or 2 10 thousandths. Okay, how about this one? Pause the video, try it on your own, then we'll go over it. Okay, this one is a little bit different because now I want to break both of those numbers up. Now, you might find that after you do a few of these and you practice them, that you keep one number as it is and you break the second number up. I tend to break both of them up. I tend to make fewer mistakes that way, but as you get more comfortable, if you find that you're only going to break one of the numbers up, that's totally fine. Okay, so I took the 9,000 and I broke it into 9 and 1,000. And I took the 7 tenths, hundreds, thousands, 10 thousandths. 7 10,000ths and broke it into 7 times 10,000. And then, because this is multiplication, I can rearrange these numbers. Okay? And I've been doing this a little bit in some of the other ones, but it's pretty clear here. And most of you know this already. If I do 2 times 3, I get 6. And if I do 3 times 2, I get 6. It doesn't matter which way I multiply them. Just like with repeated addition, it doesn't matter if I add 2 3s or I add 3 2s. Those are both the same. So in this particular problem, we're going to exploit that. And we're going to exploit that by taking the 9 and the 7 and multiplying them together out in front. So there's the 63. Then I'm going to carry down my 1,000 and I'm going to carry down my 10,000th. And now I'm looking for tens. So I need to break up both the 1,000 and the 10,000th into tens. So I took my 1,000 and I broke that into 3 tens. 10 times 10 times 10 is 1,000. And then I took my decimal part, my 10,000th, and I broke it into 4 tenths. So I multiplied by 10th, and then a 10th, and then a 10th, and then a 10th. So thinking about shifts, what's happening here? Well, we're starting with our 63, and then we're shifting 3 larger and 4 smaller. So we need to do both of those. So 63 gets 3 shifts larger and 4 shifts smaller. So if we're going to go through step by step, here are my shifts up. So 63, shifted up once, shifted up again, shifted up a third time. And now I'm going to start doing my smaller shifts. So I'm going to shift back down. So I'm going to shift down 1, down 2, down 3, down 4. So after all of those shifts, the 63 became 6 3 tenths. Now, some of you might notice that, oh, well, I shifted up and then I shifted right back down. So if you can think of these as, oh, well, 3 larger and then 4 smaller, that's the same as just 1 smaller, then go ahead and do that. So the three of the ups cancel out 3 of the downs. So those 3 larger get canceled out by 3 of the smaller shifts, so then you have 1 smaller shift. So what's happening here? 9,000 and 7 10,000ths multiplied together gives you 6 3 tenths. So estimating multiplications with decimals. So to estimate multiplication of decimals and whole numbers, we're going to use what we just talked about with place value shifts, and then we're just going to round first. So we're going to round it to a nice number, preferably one that only has 1 non-zero digit, and then we're going to do some place shifting. So for example, I have this large number and this small number multiplied together, and I want to estimate this. So the first thing I'm going to do is I'm going to round. So I'm going to round this to 80,000 times 2 hundredths. And then I'm going to break this down. So my 80,000 becomes 8 times 10,000. My 2 hundredths becomes 2 times 100th. And then I'm going to do some rearranging with multiplication. So that gives me 8 times 2 is my 16. The 10,000 gives me 4 shifts bigger. And the 100th gives me 2 shifts smaller. So if I take 16 and I shift it 4 bigger, and then I shift it 2 smaller, that 16 will become 160,000 with the 4 shifts bigger, and then 2 shifts smaller will take it down to 1,600 or 1,600. Estimating multiplication with fractions. What we're going to do here is we're going to round our fractions to whole numbers. So if you have a mixed number, or if you have a number that's very close to a whole, so it's very close to 1, round that to 1, round your mixed numbers to wholes, or we're looking for half. Or another fraction if you're comfortable with it. If you're comfortable with thirds, you're comfortable with fourths, or they make a lot of sense in the specific question that you have, feel free to round more accurately. But in general, we're looking for whole numbers and halves. Multiplying by a half means that you're taking that number, you're breaking it into two equal parts, and you're taking one of those parts. This is something that a lot of us are already comfortable with. I just want you to think about it. When you multiply by a half, it means you're taking half of that number. So for example, 4 3/7 times 9 4/5. So we're going to round and then multiply. So I would round this to 4 times 10. So 3/7, that means I'm closer to 4 than I am to 5. 4/5 means I'm closer to 10 than I am to 9. So I would round that to 4 times 10. Now, you might want to round the 4 3/7 to 4.5. And that wouldn't be bad either. 4.5 times 10. So 4 tens plus a half a 10. So that's not too bad. So 4 tens would be 40. A half of a 10 is 5. So that would give you 45. So that would be another excellent estimation of 4 3/7 times 9 4/5. 3/7 is pretty close to a half, so that's a little more accurate, but I'm totally fine with rounding it to 4. We're estimating, right? We're just coming up with an estimate that's close, but not perfect. Okay, another example, 32,567 times 5/9. So let's round it and then multiply. I would round this to about 30,000, and I would round the 5/9 to a half. Okay, 5/9, not really close to 1, so that might be a little bit of a stretch, but it's fairly close to a half. So now I have 30,000 times a half, which just means take half of 30,000. Well, half of 30 is 15, so half of 30,000 would be 15,000. So in summary, to estimate multiplication of decimals and whole numbers, round the given numbers, and then use what you know about place value shifts. Multiply by 10, place value shift 1 larger. Multiply by 1/10, place value shift 1 smaller. Round fractions to whole numbers or halves, or another fraction if you're comfortable with it or it really makes sense for the estimation that you've been given.